Hope you can see that. Happy Pi Day. And if you're a Taoist, it's Happy Tau over 2 Day. Let's get started. You're going to learn to draw on the TI-Nspire CX II. My name is John Hanna. You can reach me at johnehanna@gmail.com. Longtime T³ instructor and a strong advocate for programming in the math and science classrooms. My handout is already up online at my website, www.johnhanna.us. So let's get going. The first thing you notice is the program I just had running there. Learn to draw. Here's a screenshot of what we did there. It's got a little red rectangle around it and an ellipse around let's go. There's some colorful text down in here. And all of that is done using the draw commands inside the TI-Nspire basic programming language on the CX2. About the handout, we'll put this aside for a minute and look at the handout. Get back to the beginning page. Up. There we go. The first page is a sample of some of the things you can do with the drawing commands in TI-Nspire CX2 TI basic language. But these are all static pictures. I'll show you some demos later on of the animation and manipulation that's possible up there. Yes, that is a TI Connect 4 game, TI Connect 4, huh? On the second page is all of the drawing commands and their syntax. So it explains a little bit better than what you can get off of the menus. I've left out the fill commands because they're the same as the draw commands. There's a little sample program at the bottom too. The third page is the one that I got from Peter Fox from Australia. He has a webinar that he recorded online and it's available on YouTube. And I want to emphasize two things. One is the power of the mathematics involved in graphical programming. And the second thing is down at the bottom of his program, he uses a very handy little tool to stop a program whenever you press the escape key. Because the fourth page is all of the strategies, not all of them, but some of the strategies for using the getKey command in your programs. Because once you start up a drawing program, there's no other control except to break the program or stop the program. And the getKey command makes it more interactive, as you'll soon see. So that's the handout. Again, it's already on my website. If you go to johnhanna.us, it's up here somewhere, right here. Oh, before I get into that, notice that I have a crossword puzzle of the day on my page. And the first answer in the crossword is arcs. I'm wondering if that's a coincidence or if they're celebrating Pi Day, because I haven't done this puzzle yet. Puzzle changes daily. If you click on the red TI-Nspire button, your handout is right here at the top of the page. It's a long page, so you can scroll down at your leisure. Back to my work, because where the real meat of the matter here is programming these draw commands. So on the next page is the overview of what drawing is all about. The draw statements produce a drawing canvas. First one that occurs in the program will pop up a screen that you wouldn't recognize unless you were drawing graphics in a TI basic program. And that drawing or that graphic screen cannot be closed until the program ends. You're stuck on that screen, whether you're using the computer software or you're using the handheld. That screen has to go away before you can do anything else in the TI-Nspire world. It responds to keystrokes by using getKey, but it does not respond to mouse clicks, mouse downs, mouse moves, like other event-driven software. You can only write programs. You can't write functions using draw commands because that's not a function's intent. And you can only run it from the calculator, not from the Notes app, like you can with TI Basic other programs. They can react to other variables changing in your applications and cause things to happen. But the calculator is the only place where a drawing program will run. The canvas size is 318 by 212. I mentioned that because you saw some code in Peter's demonstration, and we'll be using those numbers immediately. The current CX2 OS is 5.1.3, and the drawing features have been there since about a year ago. Ignore this. I'm not going to talk about the stars on each page. That's in case you get bored with what I'm saying, and you can always look up some useless trivia at the bottom of the page instead. Next page. Next page. Come on. There we go. So my agenda is to write 3 programs: a static program, which is just a flat drawing, an animation, which will make something move by itself, and interaction, where you use the arrow keys to move things around on the screen or move something around on the screen. And then there's more stuff to come, and you're going to be impressed with what happens at the end, I hope. Project 1 is the smiley face, the mother of all emojis. And in this program, we're just going to do some simple drawings to get something on the screen that we can appreciate, give you a feel for the environment and how the drawing commands work. By the way, if you're interested in grabbing a screenshot here, it's handy to have your smartphone available, and that way you can snap a picture of the current screen. I'll try to leave stuff on long enough for you to browse and appreciate the work that's going on under the hood, because I'm doing all of this live, including the program. So I'm starting a new program. I happen to call it Smiley, but there's no code in here yet. I'm going to press the menu key on my calculator. And normally when I'm doing this by myself, I usually use this tools key up here because they are the exact same menu. So I only use the calculator if I'm trying to teach the programming steps like I am today. But in actual practice, I'd rather use these commands over here because they're easier to get to, and I don't always have the calculator keypad available on the left side of my screen. On the draw menu, there are 2 submenus, the shapes and the control. The first statement I'm going to use is to set a window. So on the control menu, I'm going to choose set window. The window that we're most familiar with in the graphing world is something that we old guys refer to as the Dolciani window, or -10 to 10 and -10 to 10 in both directions. But on the calculator, since the windows or the screen isn't square, we use -10 10 in the X direction. And I'm going to use -7 7 in the Y direction. In the graphing app uses a default window of -10 to 10 and -6.67 to 6.67. But -7 to 7 is close enough. We're going to draw a circle. We press the menu key, select the draw menu, and it's easiest to get to the draw menu by pressing the up arrow key rather than the down arrow key 8 times. And then choose shapes and draw a circle. The circle is going to be centered at the origin, 0, 0, and it's going to have a radius of something less than 7. Let's try 6. At any time during the development of a program, you can run the program to see how it looks and then come back and make changes to the program later on. So let's see what happens when I run this program. Control R, pastes the program onto the home screen, and then pressing enter runs the program. This is the beginning of my smiley face, but it needs work. For one thing, it's supposed to be a yellow filled in circle rather than just a black circumference of a circle. So we go back to the code by pressing, oh, this is the graphing screen. I forgot to mention that. At the top of the screen, you'll see either running or finished. And it takes up the entire screen. And the only way to get out of this screen is to either click on it. If it says finished, you can click on the screen, or you can press any key. And you're back to the calculator app. So that graphing screen resides above the calculator app. It flashes onto the screen. And the only way to get rid of it is to make sure the program finishes and then click or press, click on it or press a key to make it end. Back in the program, go back to a 1 page, and instead of draw circle, we want to use fill circle. Notice that I can type in the command instead of picking it off of the menu. Just edit the command and replace the word draw with the word fill. But this is going to fill a circle in black because we haven't told it what color to use yet. If I want a yellow circle, I have to put a statement before the fill circle command that I'll get off of the menu this time. Menu, draw, control, and set color. The set color command lets me choose the color by providing the red, green, and blue values of that color. My yellow is one of my favorites because I don't understand how it works. It's 255, 255, 0. That means red and green. Why do red and green make yellow is a job for the physicists. But it works. If I press Control R and enter, I now have the yellow circle. Escape, and back to the program. Control left. Now we have to make the eyes. I don't have an image of a smiley face, but the eyes kind of look like ovals or ellipses. And in order to draw an oval or an ellipse, we're going to have to use the draw arc command. On the draw menu, this sounds weird, doesn't it? Shapes, draw arc. Let's use fill arc because we want it filled in black. Fill arc. This is one of the most challenging commands in the whole system because filling an arc, let me look at my handout again. Page up, page up. Where is draw arc? Right here. Draw arc is just like draw a rectangle, except it has a start angle and an arc angle. Draw a rectangle has X, Y, width, and height. That means you provide one corner and then the width and the height of the rectangle. In draw arc, it's the same thing. X, Y, width, and height, and then a start angle and an arc angle. The draw arc command draws an arc inside of a rectangle, tangent to all four sides of the rectangle. We call it an ellipse, and that's what you'll see happen next. Back to our program. Fill arc. Let's try, just for laughs, 0, 0, 5, and 4. But this is going to be drawn in yellow as well. So before we fill the arc, we have to change the color that we want inside the arc using that set color command. It's convenient to copy and paste in the editor by holding the Shift key down as you select the text, then press Control C, go down to where you want it pasted in, and press Control V, just like in any other computer software. Now we have a set color command which changes it to yellow. We have to change the numbers to black. 0, 0, and 0 make black. When I run this program now, what did I forget? The start angle and the arc angle for the fill arc command. 0 and 360. A word of caution though, that 0 is the starting angle and the 360 is how far around the circle you can go. Press run again, Control R, and that's not too bad. That's one of the eyes, but it's tilted the wrong way. It should be vertical rather than horizontal. So maybe if I just reverse the two width and height values, it might look a little bit better. So let's change the width to 4 and the height to 5 and see what that does. Control R. Not too bad, but I'm sure you can do better once you get your hands on this. Escape. What about the other one? We need another eye in here. I'm going to use another fill arc command, but the numbers are going to probably have to be different. Control C and paste it in, Control V. I don't want this one to start at 0, 0. I want it to start further to the left on the screen. So I'm going to try -3. Keep the width and the height the same so that the ellipse is the same size. Control R. A little too close together. And again, once you get your hands on this, you'll be able to tweak the values in here to your liking. The final step in this project is going to be to draw the smile itself, and that's just another arc. So back in the code, we want a black arc, so we're going to stick with the color 0, 0, 0, and we're going to use a fill arc command. Well, let's use the menu this time. Menu, draw, shapes, fill arc. And where do I want this arc to be? Somewhere on the lower left. I'm going to start on the lower left-hand side of the screen in the smile and work its way to the lower right and be a smile. So I'm going to start at, say, -2, -2, with a width of 4 and a height of 3, and go from, this is the tricky part for this arc now. Think of the clock face, where 0 degrees is to the right, 90 degrees is up, 180 is to the left. So I'm going to start around 190 and go for, let's see, I want to go 10 degrees below 360, and 190 from 360 is 160 or something like that. I'm going to try 160 for now and see how that looks. Whoops, that's a filled arc. I don't want a filled arc, I just want to draw the arc. We go back to the code and change fill arc to draw arc. And this time we get a little smiley face. And again, giving this project to students and let them play with the numbers gives them a good experience in working with the graphics positions. You notice I don't see an X and a Y axis on this screen. It's inherent in the window, but it's not explicit like a graph screen is. So we're going to quit here and leave it at this, because this gives us a feel for what a graphics drawing is going to look like. Here's the entire program. We'll leave this on the screen for a moment if you need to take a picture of it. The set window command establishes screen coordinates. In the next project, we'll ignore that and use the default screen coordinates. Set color is used to establish the next graphing color. Fill circle and fill arc and draw arc are pulled off of the menu to draw that particular shape. Again, the draw arc command is the most challenging for me because I have to think in terms of lower left-hand corner and then how wide and how high the arc has to be. So in place of that, I write my own draw arc routine that goes like this. And instead of using the lower left-hand corner and the width and the height, I use the center of the arc as my first two arguments, the X radius and the Y radius of the arc, and then the start angle and the arc angle, the same as the draw arc command does. And I let the draw arc command in here calculate the lower left-hand side corner and the lower left-hand corner Y, twice the X radius and twice the Y radius. So it's possible to write your own customized routines as a subroutine and then use those instead of the ones that are built in. So this is what draw arc centered at 159, 106 with an X radius of 100 and a Y radius of 50 going from 90 to 180 looks like. Again, this is the default screen. So 159, 106 is the center of the screen, and it goes to the left 100 and up or down 50 to establish that rectangle. Going from 90 to 180 makes it draw the left half of the ellipse. If I go from 90 and make the arc angle 360, then it draws the entire ellipse. You can draw either horizontal, major axis horizontal ellipses or vertical, but with this draw arc command, you can't draw oblique or diagonal ellipses. We'll leave that as an exercise. Next, project 2. Oh, by the way, if you're watching this on video, you're recording this, they are recording it. If you're watching this on video, each of my sections has that yellow and blue banner on top of it. When I'm done with this project, I'm going to save this file and print it as a PDF on my computer and upload it to my website. So while I can't share this TNS file with you for reasons that you'll see in a little bit, I can share the text of the file with you in a PDF document, and you'll be able to review all of this work the way I leave it at the end of this session. So now we're going to make a dot or a circle move across the screen. Empty program again, program move dot. In this case, we want the X and Y coordinates to vary. So we're going to use variables in the program instead of fixed numbers like I did for the smiley face. X is going to start in the center of the screen. Remember, I said that the screen is 318 by 212. The center of the screen is 159 in the X direction, and the Y direction is 106. But I'm using the wrong symbol in here. I need to use the colon equals, which is on the control templates key. Colon equals means gets. I learned recently that that is also called the walrus operator because if you tilt it sideways, it looks like the eyes and the tusk of a walrus. And this one had to be control equals. So Y gets 159 and X gets 106. Now for the loop. We're going to make this thing move until we press the escape key. This is where the getKey command comes in very handy. I'm going to put a while loop in here. Menu, control, use the while loop. And the command, the condition that I'm going to look for is when getKey 0 is escape. So we'll use the getKey command, which is on the IO menu. Pressing menu, IO, getKey. And I like to put a 0 in here, and I'll explain that a little bit better in a few minutes. Is not escape. On the control equals key, we have the does not equal sign. And in quotes, if quotes is the multiplication key. Where is it? Quotes. Blink. Quotes. And then ESC. Each key press returns a string value representing the name of that key. So the name of the escape key to the getKey command is ESC. The tab key is TAB. The enter key is ENTER. The space bar is SPACE, etc. Inside the loop, this means that when I press the escape key, the program or the loop will end. And I want to draw a circle, or let's use a filled circle. I want to draw a circle at the X and Y position, the current X and Y position. So we press the menu key and choose the fill circle command from the draw menu. Menu, draw, shape, and we're going to choose fill circle. We're going to use the X and the Y coordinates as the value of the center and a radius that's not too small and not too big. Let's try 10 for now. If I press Control R now and run the program, it should run and fill a circle at the center of the screen, if I'm right. Control R, use move dot, and there it is. Notice that the program on the screen says running in the upper left-hand corner. The program is still running, and I can't do anything else like press menu or press escape, or not escape, that's the one that will work. I can't insert geometry because the program is running. So I can't do anything until this program ends. I press the escape key to finish the program because that's what I told the computer to do in the code. While getKey 0 is not escape, keep filling that circle at the center of the screen. Now for the movement. I want this point to move to the right, the black dot, move to the right every once in a while. So I'm going to put in an increment on the variable X, which is the X coordinate. X, control equals, colon equals, X plus a 1, and then Control R to run it again. And escape. So the circle moved to the right and it left a trail behind it. Escape and back to the code. In order to get rid of the trail and only move the circle but not leave a trail, we need to add the statement, erase the screen. It's called clear. Menu, draw, control, and clear. And this command clears the drawing canvas. When I run it now, the circle moves to the right and goes away. The final step here is to make it move somewhere else except all the way off the screen to the right, because it'll just keep on going because I haven't told it to do anything but increase the value of X by 1 in here each time. Well, the next step is to fix what happens when it goes off the screen. If is going to be used in here. We choose menu, control, if. Which one do I want to use? I'm going to use the simple one. If X is greater than, what's the right side of the screen? 318, colon. Colon is down here on the, where's the colon key? Punctuation marks key. You'll find it on your handheld right there on the punctuation marks key next to the G key. Or you can just type it in if you're working on a computer. If X is greater than 318, I'm going to say X gets 0. Control R and enter. The circle moves to the right. And when it goes to the end of the screen, it goes to the beginning of the screen instead. So as an exercise, your job is going to be someday, instead of making it constantly move to the right, how about making it move to the right? When it gets to the edge of the screen, turn around and move to the left. And when it gets to the left edge of the screen, make it move to the right again and have it bounce back and forth. Also, about making the Y value change as well. We haven't done anything with this Y coordinate. It stays at 106. And so we can do a lot of other cool things in this loop by making changes to the X and Y coordinate. A little hint, instead of X gets X plus 1, we're going to have to use something like X gets X plus dx, where the dx is the change in X, and dx will change value from +1 to -1 somewhere in your program. So that's a plain animation. Our next project is going to be the interaction. We can control the position or the movement of this dot using the 4 arrow keys, which are named up, down, left, and right. When you use the getKey command and you press an arrow key, then the words up, down, left, and right are going to have to be taken into account in this program. So the code is going to look pretty much the same as before. Why don't I just go back and copy the code from the previous program and paste it into this program? Why reinvent the wheel? So back in the last program, I'm going to start with the same big idea, and we'll just change the code inside that while loop. So copy this code. Hopefully this works. And in this program, paste the code, and nothing broke. So I'm very happy about that. Instead of this while getKey 0 is not equal to escape, I'm going to change this to the variable K, which represents the key press. At the beginning of the program, K has to be assigned a value, because if you use K before it's been assigned a value, then this statement will not know what to do because K is undefined. So I'm going to say K control equals K gets nothing. This is an empty string. K represents the empty string. So at least it's not escape, and this loop will be allowed to continue. Yes, we're going to use the fill circle command, but in place of X and X plus dx and so on, we're going to take out the edges of the screen too. We want to add in some statements that let us know which key is pressed and what to do when that key is pressed. So I need a getKey command in here. Okay. Control equals getKey is on the IO menu. 0 again, for laughs for now. And what do we do? No. This time, let's use a 1. Now I'll explain why the difference. getKey 0 searches for a key press, but doesn't stop the program. getKey 1 is like an input statement. It stops here and waits for you to press a key, and then it will proceed. So the getKey 1 argument locks the program into this position right now and pauses the program until a key is pressed. Now we have to process the key that was pressed using a bunch of if statements. Menu, control, if then, end if. So here it pastes in the block of code, if then and end if. And I'm going to use this 4 times. So before I start messing around with this, I'm going to copy and paste paste, Control Z, undo. Let's do this again. Control C, Control V, Control V, Control V. So there are 4 if statements in here. In the first one, we check to see if it's the up key. If K equals, quote, up. In the second one, we check for the down key. K equals, quote, DOWN. In the third one, for the left key, K equals, quote, left. And in the fourth one, the right key. I have about 20 minutes left, right? I see that. I'm watching my clock. And what happens when I press the up key? Look at my coordinates. Remember the screen is, let's see what happens right now. So the dot is in the center of the screen at 159, 106. If I press the up key, what's going to happen to the value of y? I'm not watching the chat window, so I can't see your answers, but I'll provide that myself. Up here in the upper left-hand corner is 0, 0. Down in the lower left-hand corner is 0, 212 or 211. So the y values start at 0 and work their way down the screen in the default viewing window. So if I want the y value to go, the y position or the position of the circle to go upward on the screen, I have to subtract from y, not add to y. Y gets y minus 1. That will make it go up the screen because 0 is at the top of the screen. If k is down, then I'm going to take y and add 1 to it. Left and right, the x coordinates are in their normal orientation. So to go to the left, we'll subtract 1 from x, and to go to the right, we'll add 1 to x. X gets x minus 1. We're going left. And x gets x plus 1 for going right. And the clear command is down here so that it erases the old circle and then draws the new one.
John, you need K equals right above that.
I left that out. Thank you. Equals. There we go. Did I leave anything else out? We'll find out in a second.
Hey.
Syntax error. I left out the K. How'd that happen? There we go. I'm rushing too much. Control R. Enter. Program is running. Circle is waiting for me to press a key. When I press the up arrow key, I'll use my keyboard emulator over here. Up arrow key, and the circle moves upward. Down arrow key, left arrow key, and right arrow key. But it's not moving very fast. So when I press the escape key to finish, I'm just going to change the 1 to 10. Better yet, use a variable at the beginning of the program. And that way it's easy to change just one variable rather than 4 in the code. This time, up, move it a little bit faster, right, left, and down. And there's no accounting for the edges of the screen. We'll leave that as an exercise. If X or Y goes off the screen, what are you going to do about that? And we'll pause there. So, some other demos that I have waiting for you in the wings. These are found on my website, and I was writing these over the course of the year for various reasons, just to see what you can do with graphical programming in mathematics. The oscilloscope looks like this. And I got this idea because I was watching a movie on MeTV called The Giant Claw, which has one of the worst movie monsters ever made because the producers paid $50 to have it made in Mexico. No offense, Mexicans. Here's the program. So imagine this sitting in the background of a TV set on a TV, the set of the movie, just playing this thing back and forth. And the weird thing is what happens at the two ends, here and here. Don't they look like parabolas? I press escape to end the program. And we can do this same thing without a program using the TI-Nspire.
Oh, well, you're back, so thank you. Continue, please.
Okay. I've been talking about Python the last few minutes. So this is a sample Python program. When you're adding documents to this file, there's a new command down here. I don't know if you've heard this before or not, but TI is working on adding Python programming to the TI-Nspire CX II. Again, I emphasize it's the TI-Nspire CX II only, not for the TI-Nspire CX, but only the CX2. And the Python programming language is based on a system called MicroPython, which is a smaller footprint than full-blown Python that you would have on your computer. Python code, let me start a new one and call it demo. Oops, that's basic. Control I. Let's try Python. New. Demo. And now this is a Python program. It actually creates .py files in your system. These py files will probably be available to export to other Python environments. If you're using Python on your desktop, then you'll be able to use these files as long as they are CX2 compatible. But generic Python programs are written using, I'm going to show my documents toolbox and look at the menu. So the Python editor is built to be user-friendly for students. All of the important commands are found on menus, and using an operation like an IO operation for printing, let's keep it simple, hello world, close quote. Notice the color syntax. And if I choose a command like a for loop, menu, built-ins, control, for loop, then it gives me these inline prompts as to what to fill in and what they're there for. So instead of index, I can put the variable I. For range, I can put in 1, and we'll see what that happens. And for block, I have to fill in something here. So I'll say print I, and then run this program by pressing our familiar Control R, like you do in TI-Basic. So it prints the hello world at the top of the screen and prints the numbers 1 to 9. And this is the Python shell. For those familiar with Python, we have an editor and a shell. And the shell acts like a calculator. So it behaves like the calculator app in terms of being able to process Python instructions. It's used for testing statements, and it's used for running programs or executing functions. So here's one of my favorites that I just got yesterday. Hope it runs without breaking. Run this. This runs a program that counts the number of times the number 11 appears in 11 to the 11. So the number on the right is 11 to the 11. 16 occurs twice in 16 to the 16. Right here at the end, isn't that weird? And 19 occurs twice in 19 to the 19. Back in the program, the original used 100 instead of 20. And when I run this program, it found all the numbers between 1 and 100 where n to the n occurs twice, n occurs twice in n to the n. So 96 occurs twice in here, and it happens to be once at the bottom. If you think that's a big number, try like something like 2, 3, 4, the 5, 6. Whoops, that's the wrong number. I used the wrong operation here. It has to be 2 stars for raising to a power. Or 2, 5, 4 to the 5, 6, 1. Well, went off the screen. Notice how many lines I have on the screen right now? 109. And up here is line 73. So from line 73 to 109 is the answer. One of the neat things about Python is that it has an unlimited integer capacity until you run out of memory. So first, thanks the T³ office for letting us put this stuff together. And I've been looking forward to this for a long time. If you're interested in more Python information, there's an email address in this document, inspirepython@list.ti.com. And there's an interesting conversation printed online with Guido van Rossum, developer of Python, who has since retired from the project and passed the baton on to some other dictator. Thanks for your time. Thanks to the T³ office. And I'm going to pass the baton back to David